This video covers review 4 over functions. So problem 1 asked me to solve. When I'm solving, I use don't call me after midnight. So I do have a -2 to distribute. -2 times 3x is -6x. -2 times +2 is a -2, and everything else stays the same. So I've done the distributing. Next, I'm looking at combining like terms, and I do have like terms to combine. So for my x's, I have -6 and +4 for a total of -2x's. Then, to continue solving for x, I do not need to move my variable to the same side, but I do need to move that -2 because I need to add or subtract. So the 2 cancels, and I have -2x equals 14. And then I do need to divide by -2, so x equals -7. Problem 2 asked me to simplify. So remember, when I'm simplifying, I'm not doing the same don't call me after midnight, but I'm doing some of those similar steps. So I'm going to take that -3 and distribute to get rid of my parentheses. So 4x is just going to be rewritten. -3 times 3x is -9x. -3 times -1 is +3. So I'm basically taking the top part of don't call. So combining like terms, I have -5x's and then a +3. Problem 3 says Miss Adams bought a refrigerator that cost $1,200 including tax. The cost of electricity to run the refrigerator is estimated at $78 per year. Write an equation that represents C, the total cost of the refrigerator over including electricity over N years of operation. So the total cost is going to equal that refrigerator, which is $1,200, plus the cost of electricity over N years, which is $78 per year. Now, we don't know how many years, which would be in, and so we're just going to leave that as it is. So C, the cost is going to equal $1,200 to buy it plus $78 per year. Then they ask me to write an inequality that could be used to help Miss Adams from problem 3 determine how many years it would take for the total cost to be more than $1,600. So we have the cost, and they want this to be more than, just greater than $1,600. And this one also just asks you to write an inequality, so we would leave it there. But we would want to know where the total cost would be greater than $1,600. Problem 5 tells me if 3x plus 12 equals 48, what's the value of 2x plus 1? So first thing I'm going to do is solve for x by using don't call me after midnight. So 3x equals 36. And don't call me after midnight. This is the bottom 2 steps because I don't distribute, don't combine, don't move. So I've added or subtracted. I need to divide. So x equals 12. So for the value of 2x plus 1, instead of x, I'm going to replace it with 12 and solve. When I plug all of this into my calculator, I get 25. Problem 6 asked me to solve for L, so using don't call me after midnight. No parentheses, can't combine like terms, don't have terms on both sides. I need to add or subtract whatever is not directly attached to L. On the left side, P and 2W are not like terms, so I will just rewrite them. And then to finish solving for L, I need to multiply or divide, in this case divide by 2. So you could see it written like this or like this. Hold on. So 2W. So you could see it where they've divided both pieces by 2 or where they just divide the whole thing by 2. Problem 7 says a cable company charges $75 for an installation plus $20 a month. Another cable company does not charge an installation fee but $35 a month. For how many months of cable service would the total cost be the same? So we're wanting to know company 1, company 2, where would they be the same? Company 1 is $75 plus $20 per month. Company 2 is $35 per month. In order to solve, don't have parentheses, don't have to combine. I do have variables on both sides, so I'm going to move the smaller one. Anytime we cross that middle line, make sure you're doing the opposite. To continue solving for m, I don't have anything added or subtracted, but I can divide. So 75 divided by 15 is 5 months. Problem 18, Jessica's having friends over for dinner. She has $18 to spend, so she orders a pizza for 12, drinks are $1.50. How many drinks can she order? So if you only have $18 to spend, you cannot spend more than what you have. So what she spends needs to be less than or equal to the money she has. Now to spend, she has $12 on a pizza. Drinks are $1.50 each. And again, that's going to be less than or equal to 18. So I'm going to grab my calculator really quickly and complete 18 minus 12, which is 6. And then I'm going to take 6 and divide by 150. And D is less than or equal to 4. So she can buy up to 4 drinks. This graph we're going to use to answer questions 9 through actually 11, not 12. So 9 asked me for the domain. Remember, the domain is all of my x values. I find it easiest to start on the left side and write all of my x's working my way to the right. So we have an x value of -5, -2, 0, 3, and 7. Range is all of my y values. So I use my y-axis for this one. You can start at the bottom or the top. I tend to start at the bottom, so I have 2 of them at -4. I have 1 at 0. I have 1 at 1. I have a point at 2. And I have a point sitting at 6 for the y's. Then it asks me if this function is a relation, why or why not. So remember, in order to be a function, if the relation is a function, not if the function is a relation. So if it is a function, then that means that the x values will not repeat. However, right here, if I complete the vertical line test, the x value at -5 repeats. You could also say vertical line test does not pass when x is 5. Vertical line test, VLT. It's completely up to you. Problem 12 asks me to identify the range if we're given the function f of x equals -3x squared plus 4, and the domain is 1, -2, -3. So remember, you can put this into your calculator. In y equals, I'm going to put -3x squared plus 4. So hopefully you've practiced that enough times to know how to do that. If not, or if you don't have a calculator, then you find f of 1 by plugging in 1 for x. Same thing with -2. Same thing with -3. If you remember how to do it on the calculator, you plug this into y equals, and you click second table or graph, either one will take you to the table. And my domain is all of my x values. So when x is 1, the calculator tells me that y is 1. When x is -2, the calculator tells me y is -8. -3, the calculator tells me -23. So that might be something, if you're not sure how to do that, make sure you brush up on it before the test. If you don't remember on the calculator or you don't have one at home, then all you have to do is plug these in exactly like you see them to the calculator, replacing those x values with the x's from your domain and figuring out what. So this page is asking me on page 3 to identify the domain and range of each graph and then classify it. So 13, domain is all of my x values. This is my x-axis, so I'm looking at x's from there to there. My x's go everywhere. Oop, that was bad. My x's go everywhere in between those x's. So if I go all the way out on the left side, this x is at -4, and all the way out to the right, that x is at 2. So remember, with domain and range, we use less than signs. It goes from -4 to +2, and everything in between those points is included. Also, those points have endpoints or full bubbles, so they are also included and use the less than or equal to signs. My y's, we use the y-axis, and they go up and down. So if I go all the way down, it goes down to -6, and then I go all the way up to 6. Remember, we look at the entire graph, not just the endpoints. So the range for this would be from -6 all the way to +6, and everything in between. And then this would be a continuous graph because it continues moving. There's not little dots. Problem 14, I'm going to identify that this point is at 9, -4. My x-axis is the one that goes side to side, and my x's from this point go to the left, which is less than. They get smaller. So my x's will be less than 9 and cannot equal 9 because there's an empty bubble. My y's start at 4 and then go up, so I'm framing that point. So my y's going up from -4 are getting bigger than -4. This graph is also continuous because it has a straight line or a line. Problem 15, my domain is my x's, so my x's go out on the left to -2 and go all the way to the right to 4. So -2 has an open bubble, I leave it open, but 4 has a closed bubble, so I do the, sorry. And then my y's go all the way down to -3, all the way up to, oh sorry, that's not a -3. Go all the way down to 3 and all the way up to 7. So they go from -3. At -3 we have an open bubble. 7 is closed. Oh, it's not a negative. Sorry, y'all. And then this is a continuous graph because there are not blips or stops. It is one line. Problem 16. My point is at -3, +5. My x's are left to right. These are going from -3 and getting bigger because they're going to the right. As I go from -3 on the x's, going to the right gets bigger. And then the y's are at 5, but they are going down. So my y's are getting less than 5. Both of these are less than or equal to, greater than or equal to, because there is a line under the inequality. And this would also be continuous. 17 and 18 just ask us to identify discrete or continuous, and both of these are going to be discrete because they have very broken up specific points, not a line. Less than or equal to on that one. Uh-oh.